Hey, what's up? Jason here from Unity3D.college. Today I want to talk about reflection and how you can use this in your Unity projects to kind of simplify your code and make things a little bit more generic, save time, like I said, just make things generally cleaner. So if you look here at the Microsoft documentation for reflection, it just says that reflection provides object types of type that describe assemblies, modules, and types. You can use it to dynamically create instances of the type, to bind to an existing object, and blah, blah, blah. Essentially, you get a type of an object that you can use, or you get a type object, and you can use that to, examine your classes and instantiate or spawn up new versions of those classes. And then also to view the properties and, set data on those properties. So there are a couple different cases where I tend to use reflection. One is for very generic data loading. So say I want to load a table, from a SQL server directly into an object, and I'm not using something like Entity Framework. What I'll use instead is just reflection, where I'll get the data, look at all of the columns, compare those to the type names or the property names of the type, and then just set the data using reflection. In fact, let me show you that real quick. So take, for example, this case where I need to pull in an entire table of ability definitions from a table, and I don't want to, hard code all of this stuff for which type or, which columns I'm pulling in and map those all manually to fields on this data type. Instead, I just create a little helper that reads it, and then this just pulls in the SQL, but the cool part is down in this mapper. So here we just use a mapper, and I think you can find copies of this online. This is a pretty simple, pretty common pattern. But essentially, getting all of the column names of this data table that's getting pulled in already, and then getting all of the properties of this type. So T entity is generic, so here I can do, it could be an ability definition, it could be an NPC, it could be a spaceship. It doesn't really matter. It just has to be, something that's a class. You can see right there on the screen. And a little tooltip, if I move it, though, it's going to go away, that T entity is required to be a class. So anyway, we get all of the properties, and then go through each of the rows, and then map the value of the column basically to that property name. And here, I'll just dive into here a little bit more and show you kind of how this works. So if we look at, let's see, where are we getting the so we've got the property info right there. Oh, right here. Sorry, I went a little bit too deep. Anyway, so here it is. We're going through each property. So here we got all of the properties on the type, turned them into a list, and then just loop through each property, and then we use this method right here to map the value from the row with that property onto this entity. So essentially, we're using reflection to figure out what the properties are, just make sure that they match up with the columns, and then fill them in. This is a pretty simple, pretty common use for something like this, or pretty common use of reflection to do something like this. But I've also got another case that I think is even more interesting and a little bit more common. And let's jump over to that right now. So if we go into this effect factory. So the way I've got things set up, abilities have effects, and effects are the things that do the actual thing. So they could heal you, they could measure you, they could do damage to you, they could stun you, snare you, kill you, anything like that. In fact, I'm going to show you the process as I create a new one in just a few minutes. But the way it works, we have all of these ability effects. If I go to ability effect, see, it's just got essentially a type. This is the important part. It's got an ability effect type with a getter that's abstract. And it's an abstract class, so it can't be implemented on its own. You have to actually inherit from it to put it in. Now, when this thing starts up, what we do is go through and register each ability effect type using reflection. So here you see, just get all of the types available by going into the current assembly and looking for anything with an ability effect as its base class. And then once I have that, I dump it into a new dictionary. So here we just create a dictionary for our ability effects, and then loop through each type, instantiate one using activator.createInstance. This is that method that allows you to instantiate something or create something using reflection. Just talked about a little bit, right here on the what did it say? To dynamically create an instance of a type. So here in the code, remember, we don't necessarily know the type, or we're not hard coding the type at least. We're just pulling the type by looking at this assembly through reflection. So what does that give us? Well, let's take a look at like effect heal. Now this is really basic. It's just got an ability effect as the base class with a type for my targeting. And then the important part though is right here. So here we just override that effect type and put in the new effect type value, which is just an enum, and we just add a new one, add a new effect, and it all works. So the real benefit here is that now if I want to add in a new effect type, I can just create a new class, make it public, and then make it inherit from ability effect. And then since this is going to be modify scale, the way I've got it set up is just with generic, so I can specify a minimum target interface. So this would be like something like a I move. I believe that is probably the correct interface, and because that's going to have access to a transform that I can adjust the scale on. And then I just implement the abstract class, get rid of that default implementation there, and add a getter. So do get and return ability effect type dot modify scale. So just do that. I generate the enum value. Control period there. Oh, it's not wanting to generate. Right here. Put semicolon there. And then I go add in this effect type. There we go. I just got it added in. And then I just hook up the processing here. So here I just like change the scale of the target or something. Oh, I don't think I have a transform here. I've got a rotation and a scale, but I think you get the idea. If I added access to a scale here, I'd be able to just change it. In fact, I just added it to the interface. So then I just like transform dot scale, local scale equals whatever vector 3.1. Here I gotta add the using statement times some amount, and here it'd actually be ability effect data. Oh, if I can spell right. Oh, lowercase a there, dot amount. And then I'd be done. Oh, wait. What's the problem? Oh, this needs to be cast as a float. There we go. And I'd be done, though. So now, if I want to add in this new effect type, like I just did here, I don't have to dig through a bunch of plumbing in the code. I don't have to go register this in some number of places or anything else. It just works. I just have to have it inherit from ability effect and give it the effect type so that it knows where to put that in the dictionary. Remember, if we go back over to this factory, it's filling up a dictionary right here, this ability effects dictionary, which has the type and then the effect. The effect gets created once. It's just reused. It's totally stateless. It just handles processing of something. And again, the biggest thing here is that I don't have to look around through the code. I don't have to register it. I don't have to add it into some XML or any other crap. I just put it in there, create the class, and it works. It's nice. It's almost magic, and it really simplifies and minimizes the amount of code that I have to write personally and that other people will have to write to build into the system as well. So I've seen things like this in the past where there was no reflection available, and it generally tended to turn into a big mess. Like I said, I'm talking about registering it in like 10, 20 places. This is from real experience of, like create an effect or whatever it is, and then I have to go through like 10, 15 different files and add in switch statements everywhere for this kind of stuff. It's a huge, huge mess. It's a whole lot better to just use a little bit of reflection and come up with these more, stateless, static, small classes that are doing one thing. Well, I say it's static. Static's not, I don't mean static like the keyword. I just mean like it's not changing. It's just running code, taking an input, giving you an output, and not hooking in with a bunch of other things. It's very loosely coupled and nice and clean and simple. Anyway, there are a lot of other cases for reflection that I've used in the past, but these are kind of the ones where they really, really save a lot of time. Like that data side, huge, huge time saver if you don't have to go in and code stuff for every single type of data that you're pulling in. And if you're pulling in, dozens of tables or hundreds of tables, you're just wasting your time sitting in there manually typing in like, hey, set this to this, set this to this, set this to this. And then every time you change a column or anything else, everything just blows up and you got to go back and fix it in a bunch of spots. Here, again, keep it nice and simple. Use reflection, keep stuff generic, and I guess most importantly, keep your classes small and simple. Keep them still doing one thing. I don't know if I can push it enough, but single responsibility principle still holds true, still the most important one of all the solid principles in my opinion. So stick with it. Anyway, if you have questions about reflection or just some suggestions for other places that you can use reflection in a project or other good examples that you think might be a little bit more relevant to just general developers, I think a lot of smaller projects, it's harder to come up with really good use cases for this stuff. So if you have some of those, I'd love to see them just down below. Just drop a comment, share where you've used it before or where you think it could fit in. And then maybe I can revisit the subject a little bit later with a couple other simpler examples as well. All right, anyway, thanks for watching. Don't forget to like and subscribe and have a great day and a great weekend.